I am Allison Schneider, and I am from AgeWell, Canada's Technology and Aging Network, and I'm the Education and Training Manager there. So welcome to today's AgeWell webinar, Building Climate Resistance, Resilient Indoor Environments for Older Adults During Extreme Heat and Wildfire Smoke Events. We will explore the challenges that climate change, specifically extreme heat and wildfire smoke, poses for building performance and the health of older adults in long-term care facilities. We will also look at how building technologies and operation strategies can mitigate climate change risks. In this webinar, we'll hear from two great colleagues, Dr. Dahai Chi, who is an associate professor in building engineering at the University of Sherbrooke, and Dr. Chang Xu. He is a research officer in the Ventilation and Indoor Quality Group at the National Research Council of Canada. We're excited to have you both here. So this presentation will last for about 45 minutes, and we will have 15 minutes of Q&A to follow. Please post any questions or comments you may have for the Q&A, either in the chat or in the Q&A box. You may also raise your hand to ask a question verbally. The raise your hand option is in the Zoom toolbar. If selected, we will unmute you and you can ask your question verbally. You can also enable closed captioning in Zoom if you'd like to see the words written out below. We're not monitoring this, so hopefully it's pretty accurate, but that is also located on the Zoom toolbar. Okay, so this webinar is being recorded and will be available for replay on the AgeWell YouTube channel. We will send all webinar registrants a link to the recording, as well as to any resources shared during this session. So without further ado, I'll stop sharing and I will invite our presenters to kick off their presentation.
Hey, thank you very much, Alisa. So I will share my screen. So can you see my screen?
Yes.
Good. Okay, thank you everyone. So my name is Dahai Chi. Today I will present with my colleague, Dr. Chang Shu, for the topic about resilient indoor environments for senior person during extreme heat and wildfire smoke event. So first of all, I would like to introduce briefly about myself. I got my PhD degree in building engineering at Concordia University in 2016. And then I worked as a faculty in 2018 at the University of Sherbrooke as an assistant professor. So now my research interests focus on the thermal airflow to achieve a safe, healthy, and energy efficient building environment. So this is my research grant, publication, student supervision record. And now I'm also a chair of Building Performance Simulation Conference, that is ECIM 2026 conference. So my research is about the airflow for a climate resilient built environment. According to the outdoor temperature, I categorize my research into three subtopics. The first one is when the outdoor temperature is very high, that is 5, like forest fire, fire safety for renewable energy, and building fires. And another one is when the outdoor temperature is high, like in summer, there's heat waves, urban heat island effect. And during the winter in Canada, somehow the outdoor temperature is pretty low. It would be the cold waves, like in the last 2 weeks in Quebec and also Ontario, the outdoor temperature is pretty low. So we focus on the indoor air quality, especially because the windows are closed during the winter. So let's back to today's topic. So actually in Canada, we know that the global, in the world, the global population aged 65 plus has increased significantly. Let's see animation here. So we can see here there's the lowest level in the 1950s, the population, but in 2100, the population for senior person could reach to 2.4 billion worldwide. And then for Canada, the 65 years old plus population will reach to 16 million. That accounted for 30% by 2100. This number is higher than the global average value. Okay, so we can see here, meanwhile, as we all know, the climate is changing. It leads to the heat waves and wildfires. And wildfires and heat waves are intensifying globally, with record-breaking temperature more than 50 degrees Celsius in multiple continents in the world. For example, in North America, in North Africa, in Asia, Australia, the temperature could be more than 50 degrees Celsius. In Canada, the recorded temperature is near, reach to 50 degrees Celsius. So this gives a very challenge to human health and infrastructure, especially in regions where wildfires and heat waves are intensified. Well, let's back to the numbers in Canada. So forest fires due to the climate change and the burned area in Canada have increased significantly since the 1980s. So the left figure shows the distribution of major forest fires in Canada between 1980 to 2024. We can see that the forest fire, not just in the West, but also in East Canada and also Northern Canada. And now for the right figures, we can see that especially in the year of 2023, all across Canada, the burned area increased significantly due to the wildfire. These wildfires gives a great challenge for our lives, especially for the senior person. The outdoor wildfires have significant emissions, including the particulate matter, the VOC, the gas pollution, and PS, and also the heavy metal. This will be transported with the smoke, and transport into the buildings through ventilation, racks, open windows, etc. For the senior person, it is they are more vulnerable to heat waves and wildfires because there's a reduced lung capacity, weaker respiratory muscles. For their kidneys, there's a decreased functions make it harder to regulate fluid. And also for their heart, their cardiovascular system is less efficient and cannot easier increase the heart rate. And also they reduce their weighting and produce less sweat, which is the primary cooling mechanism. And also there reduced the blood flow to skin. So all of these brings challenges for their thermal comfort because during the heat waves, it increases indoor air temperature beyond the threshold of thermal comfort that is normally between 26 to 28 degrees Celsius. It will cause psychological stress for the senior person, reduce the sleeping quality, and dehydration, etc. And also the senior person will have specific symptoms such as dry mouth, fatigue, stress, headache, etc. And then we can talk about very tough issues during the heat waves and the wildfires. There's some senior person passed away. For example, the left figures shows the heat-related deaths between 1981 to 2022 for different age range. So from this figure, we can see that for the men, there's the highest number of deaths between 45 to 64, while for warmer, the largest number is 150 deaths, and for the age more than 80 years old. So this is because generally women has higher expected life. The right table shows the death number for different years with the heat waves and wildfires. For example, in 2010 in Quebec, there's around 280 deaths. 80% of the deaths are the senior person, because during the heat waves, there's many of them did not have air conditioning and they are living alone. Another significant death number happens in 2021 in the province of British Columbia. So we can see the details about this event and the lessons from the 2021 British Columbia. So in 2021, there's a very high temperature during the summer. In Western Canada, so the temperature more than 20 degrees Celsius above the normal temperature, and breaking 103 all-time heat record. And in the town of Linton, recorded 49.6 degrees Celsius on June 29. And this is the highest temperature ever measured in Canada. Meanwhile, there was compound disaster because the wildfire also happens due to the dried air and extreme high temperature. So between June 25 and June 1st, 2021, there is more than 600 confirmed heat-related deaths. 67% of victims were over 60 years old, and 56% of them were lived alone. 98% of the deaths occurred in indoor. And that's why the indoor environment is very important for the senior person. So let's focus on how can we mitigate the impacts of heat waves on the indoor environment. So as an engineer in building engineering, we focused on explore the advanced building technologies to mitigate the problem. So the International Energy Agency has a subtopic about the energy and in buildings and the community program. And we have a project is NX80. It's called Resilient Cooling of Buildings. And I am the subtask C leader focused on the field studies. So I lead this report with Dr. Chang Shu in 2024. So you can download this report from the IEA NX80 website. So we can categorize 4 building technologies. The first one is to reduce the heat gain to the indoor environment. It includes the advanced solar shading, advanced glazing technologies, green roof, green facade. The second one is to remove sensible heat from the indoor environment by ventilative cooling, thermal mass utilization, evaporative cooling, compression refrigeration machines, natural heat sink. Third one, to increase personal thermal comfort apart from space cooling by comfort ventilation and elevated air movement. The last one is to remove latent heat from indoor environment. So let's focus on the first one, reduce heat gains to the indoor environment and advanced solar shading. So a wide range of properties are used to characterize the energetic performance of window. But the most important shading parameters that affect cooling load are the quantity of solar heat gain admitted to the buildings. The solar heat gain can be controlled by various shading technologies available in the market, including but not limited to between glass shading solution, solar shading integrating renewable energies, etc. The second one is about the advanced glazing technologies. And traditionally, windows have been constructed using transparent glass, which facilitate excellent light transmission. However, this traditional approach also leads to substantial heat transfer, resulting in a significant impact on a building's energy consumption. Advanced glazing technologies offer a solution by using the benefits of natural light while mitigating issues such as excessive heat gain, glare, and fading. One crucial parameter in glazing parameters are the transmission of daylight measured on a scale from 0 to 1, and various advanced glazing technologies have emerged, such as smart passive glazing and smart active glazing. And then the green roof or the green facade. It is the passive cooling technology, which means that we do not need any energy consumption. So this cooling method relies on the vapor transpiration from plant and substrate. Its effectiveness depends on factors such as water retention capacity, water supply, plant species. And by using these benefits of evapotranspiration, adding mass and thermal resistance values, this cooling technology can reduce cooling loads and lower energy consumption for cooling and mitigate the heat island effect. And the second one is to remove sensible heat from the indoor environment, such as using the ventilative cooling. So what is ventilative cooling? So in this figure, we can see that during the night of summer, generally the outdoor temperature is lower than indoor. We can open the windows. So there's a natural ventilation, or we can use fan to enhance the ventilation and exchange the indoor and outdoor air. So the outdoor cool air could cool the indoor space, indoor air. And also there's the thermal mass, such as the walls, the ground, the roof, which could be made of gypsum board or the concrete wood. They can store the cooling energy during the night. And then during the daytime, when the outdoor temperature increase, the cool energy stored on the concrete could be released, so it could cool down the indoor temperature and could save energy for cooling. So the thermal mass is very important for the ventilative cooling. So for example, in the summer, the outdoor temperature is lower in the during the night, so we can use ventilative cooling. And also during the winter, we can make full use of solar energy to store the heat in the thermal mass. And during the night, we can release the heat stored in the concrete or gypsum board. Therefore, actually, we can see the blue line in the right figure, and the red line is the outdoor temperature. So the outdoor temperature could vary significantly during the daytime and the nighttime during the summer. However, because of the thermal mass stores the energy, it can reduce the variation of indoor temperature, like the blue line. The temperature difference could be 6 to 8 degrees between the peak external and the internal temperature. So this is pretty important for the senior person, because as we see, the senior person, their sweating is less. So they are not so resilient to the outdoor temperature as the young person. So the stable indoor temperature is pretty important. The second one is how to mitigate the impacts of wildfires. So according to the guidelines for cleaner airspace during the wildfire smoke events issued by the Health Canada, we can use the following measures to reduce the impact of wildfires. For example, proper sealing windows and doors to keep them closed. So the outdoor smoke infiltration will be reduced. So we also need to install a high quality air filter to remove the PM particulate matter from the incoming air in homes with forced air ventilation. We can also set the HVAC system to recirculation mode, or we can limit use of exhaust fan like the cooking, right? Not cooking during the wildfire events. The other strategies, for example, we can use portable high efficiency particulate air filters to reduce the indoor particulate levels. And also we can use the air conditioning and the humidification, dehumidification to maintain the indoor humidity level between 35% to 50%. That is very important for the thermal comfort and also to maintain good indoor air quality, moisture. And also we need to install and maintain at least one seal alarm in the home. So my PhD student Ahmed did a parametric study to investigate the impact of using the HEPA, the minimum efficiency report value, portable air cleaner, or use the filter, and also the impact of outdoor PM2.5 concentration, the wind speed, the building air tightness, and the circulation ratio on the indoor environment. For the MERV, that is air filter levels, minimum efficiency report value, we choose the higher value, that is the level 13 to 16. So it is very efficient to remove the PM particulate parameter. The higher the number MERV is, the higher efficiency to remove the PM. So we have the conclusion that according to the result, the best situation is to use the high efficiency filter and portable air cleaner within a well-sealed building environment and most effective under low wind speed conditions. And another conclusion is that, okay, though many buildings, especially for commercial building, they have a centralized HVAC system. But if they have portable air cleaner, it will achieve the best performance for removing the particulate matter. That means the portable air cleaner acts a powerful mitigator for cases with high outdoor PM 2.5 levels. Even the environment is very terrible, like high wind speed, high level of particulate matter, and poor building air tightness. So we can use the portable air cleaner. We still can achieve good indoor air quality. So now we collaborate with NRC and Dr. Changshu for the project assessing the impact of extreme heat and wildfire smoke exposure risks in the long-term care facilities in Quebec. And the objective is to improve the indoor environment in long-term care center, which will benefit the health of senior person, reduce the health care cost for the government. So the task include installing the environmental sensors, conduct a survey, assess impact of extreme heat and wildfire smoke on indoor environment. And also we will propose a retrofit strategy and implement a retrofit. And finally, we will assess the post-retrofit performance. The two PhD students are hired for this study, co-supervised with Dr. Changshu. The first student is Dr. Student Xinsai Gan is also a research of the award, Claire Baudoin. And the second PhD will start his work in early next year. So let's back to see the research approach for the long-term care facility. So first, we will do the survey for the senior person regarding the indoor environment, regarding the thermal comfort, using the ASHRAE standard. Like if it's very cold, it's -3, very hot, +3. And then at the same time, we do the long-term field monitoring on the indoor air quality, including the CO2 concentration, PM2.5, indoor air temperature, etc. And then we can identify the issues in the buildings for a specific space. So we can do the specific test, like the CO2 concentration test in multiple positions in one space. Also measure the PM2.5, the temperature distribution. We can also use the numerical simulations like CFD to simulate the indoor environment like temperature distribution, CO2 concentration, to investigate the different building technologies like a flow rate of the ventilation, etc., to achieve the best building environment. We will also do energy simulation to investigate the energy consumption for each day, the whole year. And also we can simulate the energy consumption for each component, like the chillers, like the diffuser, like the pump, etc. So we can investigate the energy consumptions for the buildings. So that's all for my part. Next, my colleague Dr. Chang Shu will introduce his work.
Thank you, Dahai. I think you have my slides, so you can help me flip the page. So here I'm going to just save my self-introduction. I'm just research officer with the Ventilation and Indoor Air Quality Group at NRC. So if you are interested with my research, you can just scan the QR code to visit my homepage here. And I'm going to present, like Dahai said, we are working together on a field study of a long-term care home. And this is actually a part of a larger project I'm working on, overheating and wildfire smoke, focusing on to do the resilient retrofit for residential buildings like I show here on my webpage. Next slide, please. Yeah, so Dahai has already done a very thorough overview of the background of the study about the impact from heat wave and wildfire smoke events. So this project at NRC has been funded by the Climate Resilient Built Environment initiative at NRC, and we have a theme focusing on the retrofit of residential building. And of course, because senior people are the vulnerable group, so we are have extended this project to study the issue in the long-term care home with University of Sherbrooke, and so I will dive into details later. So this is a 5-year project, and for the first couple of years, we are working on the preparation and setting up a field study for the whole project, so we can do a long-term monitoring of the indoor environment condition. And then in the middle of this project, we are going to implement actual practical intervention strategies to help building reduce the overheating and the smoke issue. And to the end, we also want to leverage the result of this project to help update the national building code and standard. So we know that both the heat wave and wildfire smoke happens during the summer. So we also want to see how these two events may affect each other and if there's any synergy effect on occupants' health. So the same thing that Health Canada, we noticed the Health Canada and BC also published some guidelines document focusing on both wildfire smoke and extreme heat event. So next page. Okay, so the main tasks in this project, like I said, will be focusing on a large-scale field study over the next few years, and at the same time, we are going to also do a lab study to do the demonstration of intervention strategies, so we can verify if it's practical to implement into the buildings we are monitoring. And then with the data collected from the lab and the field, we can use the data to validate the model, a computer model, so it can be used to generalize for different climate zones, different even future climate scenarios, and even for different type of buildings. So it can help us evaluate the general impact and general benefit from the different intervention technologies. And for the field study, we rely on low-cost sensors because we want to leave the sensor in the building for long-term monitoring. And so the sensor need to cover several parameters. So of course, for overheating monitoring, the temperature and humidity are the major parameters we want to monitor. But for wildfire smoke, in most of the documents, they have outlined that the peculiar matter is the most important one, but there's also volatile organic compounds, VOCs, and other gas components in the smoke. So we couldn't include all those gas in all our sensors, but part of the sensors can also capture some different gas components. And for all those sensors, we also added the CO2 as one of the parameter we want to monitor because it's a very important parameter to indicate the ventilation performance and the occupant in the buildings. So next slide. Yeah. So here comes down to our collaboration with Professor Dahai Chi's group on this long-term care home. So this facility is located in Sherbrooke. It is the Grace Village, and it has 120 units in total, just one story, but four different wings with different healthcare levels, some with mental healthcare and some with physical healthcare. So there are different healthcare levels. So for this study, we have been dedicated to do the monitoring in both the common areas of the building, such as the living room, the corridor, the garden, even the outdoor area, and also the each individual units. So to the end, we have recruited 52 units across the whole building to capture the general indoor environment quality in this building. So you can see on the right side, we also use door sensors to monitor the operation, the door status. So we can see when the door is open or closed. And while we do the field study, you can see we are using a car to move all our sensors, and we are like a salesman to go through all the unit and to try to install sensor in their unit. So you might be curious about how we get approval from the residents, so we can install the sensor in their unit. So I'm going to introduce in the next slide is the recruitment effort. So for this study, we have been working very closely with the healthcare facility and the building manager there, and the healthcare staff for all very supportive and providing very active support. So you can see we are discussing the general design of the study and how to do the installation before this activity. And they also reminded us if we want to get approval from the residents, most of the residents are, of course, they are senior. They may have cognitive issues and they may not understand the general scope of the project. So we have designed a very beautiful flyer for all the residents and also recorded a very nice video for the whole project for the residents and the family of the residents to review. And that's why we can get a great volume of participant, the 52 units of the 120. So if you are interested, you can also scan the QR code to watch the video later. And the part of this, a very satisfying part of this project is for field study is that every time we go, we are in Ottawa and Dahai, they are in Sherbrooke, and we travel there, and we need to move all our stuff, instruments by our own cars, and we can see because of the participant and the support from the local building, we can install everything smoothly and just turn out with empty box for all the instrument and just recycle there on site. So next slide, please. So for the sensor installation, we have actually done a thorough preparation for all the sensors. We need to make sure all the readings can be comparable. So before all the installation, we need to do a sensor intercomparison in a chamber, well-controlled chamber, and those particles and measure temperatures in the chamber and to make sure all the readings are consistent. And also for the installation on site in each unit, we have discussed a lot with the local building manager about the detailed sensor location. And at first, we wanted to put it behind the TV because there's a power outlet there available. But we feel it may not capture the main active area for the occupant. So we insisted to say maybe we can do a comparison for the location 1 and 2, and to the end we find the location 2 definitely capture higher particulate matter concentration and the CO2 level, which means it is better capturing the exposure of the residents. So finally, we install all the sensor at location 2 very consistently. So next slide, you can see some of the pictures that how we install the sensors, and there's also a very nice cable management for all the sensors. And on the right, you can see how the door sensors are installed for each of the units. And during our on-site visit, we also noticed because this is a large building, the facility management is pretty good, and they have central cooling for the whole for the building in the common area only in the corridors, and that is also consistent with our previous some other projects we did in Montreal. So the long-term care home, they normally only supply cooled air in the corridor, and so for each individual unit, they tend to open the door to accept the cool air from the corridor, and some of them you can see they are using fans to draw the cool air into the rooms. So next slide would be some preliminary results. I just cooked them out yesterday night. So here I would like to quickly go through some definition about the wildfire smoke event. Definitely there's no current consistent threshold for the whole Canada, but we find from government website of Government of Quebec that the claim air quality is considered good if the concentration of PM 2.5 is below 30 microgram per cubic meter. So let's just tentatively use 30 as the threshold. So we mark up the horizontal line over this monitored period, and we can identify the 3 wildfire smoke events. And we so moving on to next slide, we have our indoor sensor installed only for the third event, after the third event in August. And we can see even for 2 adjacent rooms with very similar layout, the result can be different. And the room the room on the right may have higher particulate matter levels. And so I was considering why it comes up with this. So I look at the sensor, the door sensor data, and I noticed that the other building, 1009, they may have more time they may always have the door open, so which may have a better ventilation for that unit. And coming down to next slide is for the overheating. So also we don't have a universal definition for heat wave across whole Canada. But typically, it is defined by two factors. One is a threshold for the temperature during the daytime and the nighttime, and the other is it need to last for at least 2 or 3 consecutive days. So based off this definition, I also noticed the 3 heat wave events during the monitored period. And we can focus on the second one. It's the same period like the wildfire smoke event. So next slide is for the indoor data. So still you can see there's even larger difference in temperature. So 1007, it may have a temperature higher than 29 degrees. And normally for indoor, if it's higher than 26, it can be overheating, and 28, it can be severe overheating. So we noticed during this period also, the other room kept the door open, which means it get more cool air from the corridor. So that this means the occupant behavior in the building can be crucial to the indoor environment. So next slide, I've done a summary of the event. You can see how the two different events overlap with each other, and of the 44 days of monitoring, you actually have 29 days you may have either overheating wildfire smoke event or the extreme heat event for the outdoors, and the total overlapping days, like you have both heat wave and wildfire smoke, that is 16 days. So that is the days you need to suffer. And this is only for the outdoors, and I currently don't have the data for the indoor part. So we can add that later. Okay, so that is the setup for the field study. So I want to quickly go through some of the lab lab effort on the intervention strategies. So we have some facilities at NRC, like the test house, to test the new technologies for overheating and wildfire smoke. And also in the lab, we also have thermal breathing mannequin and airflow sensors to help capture the general airflow in a building from ventilation equipment, and to evaluate thermal comfort and the aerodynamic design of different ventilation device. And we also have a laser system, a particle image velocimetry system to visualize the airflow from a ventilation device to help them refine the aerodynamic design. So if any one of you from the industry, you want to work with us, so please reach out. So some example ideas are in the next slides. So one of the strategy, like Dahai mentioned, is to use polymer cleaner for wildfire smoke mitigation. And for this project, I have so there's a company, Rabbit Air, who is a polymer cleaner manufacturer. They donated 19 units to this project, so it can be used in the field study and the lab testing. So I have an example of the outcome from the PIV system for the visualization of the airflow. And later we are going to contribute some of the units to the long-term care home to verify their performance on site. And for overheating, next slide, is some other study we want to do, like the window films, because we know that windows are the main source of solar heat gain. And So if you have a larger window, you may have a bigger chance to get your room overheated. So the window films can do is to block some of the heat from the sun. So it helps you reduce your overheating. But at the same time, we are a bit worried about the general energy use because in Canada, we have long winters. So that's why we also want to monitor it in the winter to see how it affects the energy consumption in general. And there's some new technology claim they are all season window films. So it can not only reduce the heat during the summer, but also preserve the heat inside of the room. So we want to check if it really works like that. And the other technology in the next slide that we are working on is radiant cooling plus cooling storage technology. So radiant cooling technology is leveraged because most of the heat transferred by radiation is infrared. So, but the infrared bandwidth may not be transparent to the atmosphere, so it can be absorbed by the ambient environment. But what the radiant cooling material can do is there's a window from 8 to 13 nanometer bandwidth. The infrared emission is transparent to the atmosphere. So the material can convert the heat into this bandwidth and shoot the heat directly to the outer space. So it can get a lower temperature than the ambient air. So here on the right side is some example we are doing in our test houses. One is a direct air cooling system, which cool down air directly, and we connect with phase change material to see how they couple with each other. And the other one is a hydronic system, which cool down the water and supply it to the heat exchanger in the air handler to cool down the building. So we have two house built the same, complete the same side by side. So one of the building has implemented this system, and the other one just use a conventional cooling. So we can do a comparison in between. Okay, so next slide is a summary, I believe. So we noticed overheating and wildfire smoke during the monitored period, and we find overlapping. So both events may happen at the same time. And from the door sensor data, we noticed occupant behavior can be an important element to affect both smoke and overheating exposure. And from the outdoor data compared to the indoor, we find the Wi-Fi smoke intrusion to the building is pretty consistent. And yeah, like the finding from the door sensors, the ventilation in the common area, not just in the room, is also quite important. And we are going to explore portable air cleaners for the mitigation of Wi-Fi smoke in these buildings and in our lab. So there will be some potential collaboration opportunity, like within our expertise, we can do a whole building evaluation of the indoor overheating and wildfire smoke exposure using low-cost sensor. So to monitor all those parameters I have mentioned for older, we can do this in the long-term care home to see the exposure for older people. And we also have our lab facility. If there's any new products, new technology, you can come to us and we can help you design the study and evaluate your technology. And below there are two general email and NRC for Resilient Retrofit. So if you want to collaborate, feel free to shoot us an email. Yeah. Thank you. I think we still have time for questions.
Great, thank you so much. Really important information, I think, not only for older adults, but everyone in general, as wildfire and climate change heats up the world. So, okay, so you have your emails there, and people also can get in touch at the Resilient email. There are a few questions already, so we'll start on those, but I just want to remind of you who need a little more time to think, you can post your questions or comments in the chat or in the Q&A box, or you can raise your hand to ask a question verbally. Yeah, we have about 10 minutes, so we'll get to as many questions as possible. So I'll start with one in the Q&A box. Ibrahim asks, how will the field data from low-cost sensors be calibrated to ensure accuracy when comparing real-world measurements? So asking about calibration of the sensor.
Yeah, so I guess that question is for me. So the low-cost sensor calibration, it is low cost, it's not research grade, but in our lab, we also have research grade instrument, each like $20,000, more than $20,000 for better evaluation of the particles at different size bins. And we place all those instruments inside of a chamber, and we mix the particle with the air and use those instruments and compare to each other to see if they are having consistent reading to ensure the well mix in the space. And then we do the same thing for the low-cost sensors. So we can assume they are exposed to the same concentration, and then we can calibrate them to the research grade instrument. Yeah.
Okay, hopefully that answers Ibrahim's question. If you had a follow-up there, just let us know. There was another question about the cost of the IEQ sensors. What would be the cost? Is it low cost,
Yeah.
high cost?
Yeah, we call it low cost, but it's actually not that low cost. We know field study burns money, but it's worthwhile. It gives us real world information. So the cost of the sensor, it varies for different type of sensors according to your different requirement. Some may need a battery, some just plug into the wall, some may have onboard storage. The cost can be quite different, but we need to tailor our study based on the general environment because we are monitoring occupied space. So we need to evaluate which sensor is the best for this type of building or the room. So in general, I searched over the market. There are so many different type of low-cost sensors. Some of them can be several hundreds of bucks, and some of them can be over 1,000 and close to 2,000. So that is the general bulk number for you to consider.
Actually, these sensors are affordable. They are not very, very expensive. And also these sensors can measure multiple parameters such as the temperature, humidity, CO2 concentration, and the PM2.5. And also, so for one room, it only installed one in a representative position. And these data can be used to analyzed for their retrofit or for their diagnosis to identify the issues of overheating and indoor air quality.
Yeah, so there's a lot of benefit with one sensor. So the cost benefit analysis is that, yeah, it's considerably low cost for all of the outputs that you get.
Yeah.
That makes sense. Are these so when you're speaking about these, are these things that individuals could buy, or is this mostly institutional?
Yeah.
Like what?
Yeah. I think a lot of people, even our colleagues, may know the importance of the indoor environment, indoor air quality. They may buy one, even put in their house, in their room, to monitor what they are exposed to. Yeah, definitely they are on the market available there.
Yeah, probably in the future we can issue a guideline to help the residents to analyze the data because these data are very straightforward, and we can use a straightforward range of the air quality and thermal comfort, so people could be very easy to identify if the air quality and the indoor thermal comfort is acceptable for them.
Yeah, I think that would be fantastic and something that I think everyone would really appreciate. Definitely top of mind after COVID as well. There's a lot of
Yeah.
concerns. People are worried about their HVAC systems and other systems within their personal homes. But I was wondering as well, since we're speaking to a government worker, about some of the policies around ventilation in places like long-term care homes. I know it varies across jurisdictions, but are there any policies that could be put in place or have been put in place to assure that spaces um, are meeting air quality requirements?
Yeah, actually, there's some standard or in the ASHRAE is the American Society of Refrigerating, Ventilation, etc. It's the largest, one of the largest association for the building environment. So there's standard something like the PM 2.5, and you cannot exceed 3,000 ppm during like 1 week average value. And also for the thermal comfort temperature, normally people will see in the summer, it could be from 22 degrees Celsius to 25 degrees Celsius. But if it's over 28 degrees Celsius, it has the risk of overheating.
Yeah. So ASHRAE, I think ASHRAE 55 is for the thermal comfort. And recently our colleagues also was working on ASHRAE 44P is for the
Mm,
guideline of wildfire smoke. Yeah, and currently there's not much detail in the national building code, so that's why
yeah,
our work can be important and can recommend some updates in the future.
yeah.
Yeah.
But one thing I want to highlight is that actually, for the senior person, the thermal comfort is quite different from the young people or even because thermal comfort is quite subjective and also depends on the age of the people. As in the PPT, I mentioned that because there's less sweating and also the blood circulation, so they're less resilient as the adult. So actually, the senior person's thermal comfort should be re-evaluated even for different countries, even for the lady and the men. We need to do the fundamental study to identify the reasonable temperature or the indoor air quality range specifically for senior person.
Yeah, yeah.
I think you've
I think
identified some really important gaps. Sorry, go ahead,
Yeah,
Sheng.
yeah, I think Daha made a great point. So sometimes when the senior people may not feel they are very hot, but actually their core temperature inside of their body is already a very high temperature, which can be dangerous. So they may not notice they are in a dangerous condition. So that's why it can be important. Yeah.
That's really interesting and something I think that we haven't touched on here at AgeWell when it comes to germ technology or age tech. Some of those physical health differences, because we like to emphasize, the individual, you can't make generalizations, but there are some physical changes with age that you do have to consider. So, yeah, I think you'll have some interesting partnerships. It feels like you could go in many directions. There's a lot of potential for growth within many directions. So hopefully
no,
people will be reaching out to you, and we can connect you as well. We just have 1 minute left. I don't know. There's a couple of people with hands. If there's a really short question, Zara, I'm going to unmute you. And if you have a short question, we'll see if we can answer it. So I'm just going to unmute you now. You can unmute yourself if you have a short question. Are you there? We see you. You just have to unmute yourself. Okay. Maybe they're okay. Okay, we'll move you back, and then we'll see if Rigi has a question there. There's someone else with a hand. Hi,
Hi,
please ask your question.
I
sure.
Reggie.
Yeah, thank you so much, Professor Dahai and Dr. Chang for this great presentation. My question is, what is the metric you are using for either evaluating comfort or thermal stress, and what's the rationales behind choosing that metric? And if possible, could you also kind of give some insights which metric currently, in the literature you think is the most accurate for evaluating like indoor overheating risks?
Yeah, that's a very good question, actually. For the IEA NX 80, we have to do some metrics for the thermal comfort. Normally, we can use the PM point, the PMV, and also the dynamic thermal comfort index to evaluate the thermal comfort. And also, we have the heat stress, the temperature, like if the outdoor temperature is pretty pretty high, like more than 28, that could be a heat stress for the thermal comfort.
Yeah, yeah. So basically, temperature and the humidity are the most important direct parameter for overheating. But if you want to evaluate thermal comfort, there are multiple factors like what you are wearing, the age, and the health condition of the occupant. There are multiple parameters, but I think right now the most straightforward is temperature and the right humidity. But if you want to dive in, for example, details for senior people, you may want to develop some other thermal balance model for human body to do a detailed analysis for different age groups. Yeah.
Yeah, and also there's something like the hours of exceedance. That means how many hours accumulated is
Yeah.
out of the thermal comfort range. And also
Yeah.
there's like indoor overheating degree and the ambient warmness degree. So I would suggest you give a link about our report for the Annex 80 resilient cooling for buildings for the sub-6 sea field study. We summarize some important thermal comfort index that can be evaluated for the building. But as I mentioned, in that all these are very general index, not specific for the senior person. So it would be a very interesting study in the future, specifically for the senior person.
Yes, fantastic opportunity for someone.
Yeah, I would give the link for researchers
Okay,
who want to download the Annex 80 report.
okay, that's great. I'll share that. And then I'll also post it. I'll send a email to everybody with a link
Yeah.
to this recording, as well as a link to I think the 3 different resources we shared. This link, as well as Dr. Shu's page and the video as well. So we'll wrap up because we're a little bit over time, but I'd like to thank you both for sharing this presentation. I think it's really, really important work, and very excited for you to lay the groundwork for future discussion and to see the possible direction as we move forward. Thank you to our participants today. Sorry we couldn't get to all of your questions, but feel free to reach out to either presenter or both, or me, and we will get your question answered. That's the end of our webinar series for this year, but we'll be starting up again in 2026 in February 4th. You'll have to check out the events page. I put a link in there to see what our next webinar will be highlighting, but it'll be upcoming soon. So I want to thank everyone on behalf of AgeWell for a great year, and we look forward to seeing you in the new year as well. Thank you both so much.
Thank you, Alison. Thank you, everyone. Happy
Thank you,
holidays.
everyone. Yeah.
Bye, everyone.
Bye-bye.